We're going to talk a little bit about electron configurations, and the whole point of an electron configuration is to describe where the electrons live in an atom. So far we've started with Bohr's model of the atom, and Bohr's model had a nucleus, and then there were energy levels around the outside. Well, Schrodinger came along and he did some experiments, and he found that actually within those energy levels there were also sublevels. So we have energy levels and we have sublevels or orbitals. So energy levels are with numbers. And on our periodic table, our energy levels correspond to our rows. So we have energy level 1, 2, 3, 4, 5, 6, and 7. And this applies to this side as well. So I'm going to go ahead and number those. Oops. Now, when we get to the transition metals in the middle, our energy levels change a little bit. Instead of this being energy level 4, just like its row, it's actually energy level 3. And in this row, instead of being energy level 5, it's actually energy level 4. This one is 5, and then this last one is 6. And then when we get down to our lanthanides and our actinides, these are energy levels 4 and 5. So on your periodic table, you should have this marked somewhere so that you have this as a reference. So this is where we can find the energy levels that are occupied on our periodic table. So we could say that rubidium's highest energy level would be energy level 5. We would say that chlorine's highest energy level would be energy level 3. Rubidium's in the 5th row, chlorine's in the 3rd. So that's where that comes from. Now the sublevels are noted with letters S, P, D, and F. And those can be found in what are called blocks on the periodic table. So here we have the S block. Over here is the P block. In the middle, we have the D block. And then down here, our lanthanides and our actinides are the F block. So for each element, there is a corresponding energy level and sublevel where the electrons can live. So there can be a maximum of 2 electrons in an S sublevel, 6 electrons in a P, 10 in a D, and 14 in an F. And the whole point of an electron configuration is to describe what energy levels and what sublevels all of those electrons, where they all live. So a note I want to make here, helium, for the purpose of electron configurations, is actually over here next to hydrogen. So it's in the first energy level and it's actually an S block element. It lives on this side because it has properties like a noble gas, but when it comes to its electrons, it actually belongs over here. Okay, so the easiest way to practice these is, or the easiest way to learn these is just to practice. So I'm going to erase my periodic table. And the first electron configuration that we're going to write is for boron. So when we use the periodic table as our guide to write electron configurations, you read it kind of like you'd read a book. So when you start reading a book, you start at the beginning in the top left. So we're going to start up here in this corner. So if we're trying to get to boron, we need to follow our periodic table all the way until we get to boron. So if we're starting up here, this is the first energy level. It's in the S block. And we can fit a total of 2 electrons. So we're going to put a superscript 2. Now boron has a total of 5 electrons, and we have to find a home for all of them. So far we've said 2 live in the 1s. Well, we've hit the end of this row, so now we're going to go to the second row. We're following the atomic numbers. So this is the second energy level in the S block, and we can fit 2 electrons there. So I'm going to put the 2. Well, now I've placed 4 of my electrons. I have 1 more I need to place, and that last electron is going to go in the second energy level, in the p orbital, because now we're over here in the p block, and there's only 1 there, so I'm going to go ahead and put a 1. So this would be the electron configuration for boron. 1s2, 2s2, 2p1. So we've added 2, 4, 5 total electrons. That's how many boron has, and we started at the beginning. So let's try one that's a little bit more complicated. Let's try iron. Now, iron is number 26, so it has 26 electrons. If we're starting at the beginning, we're starting up here at hydrogen, so we're in the first energy level, we're in the S block, and we can fit 2 electrons there. Okay, so I've placed 2 of them, I have 24 more that I need to place, so I've hit the end of my 1s, so now I'm going to come to the 2s, and I can fit 2 electrons there. Well, now I've placed 4, still have 22 more electrons to go, so I'm going to keep going. I'm going to come all the way over here. This is the second energy level. Over here we're in the P block. And I can fit 1, 2, 3, 4, 5, 6 total there, so I'm going to write a 6. Well, now I've placed 10. I still have 16 more to go. I also haven't hit iron on the periodic table. So from the 10, I'm going to go to the 11. So we're back over in the S block. We're in the third energy level, S block. I can fit 2 electrons there, 1, 2. Well, now I'm out of space in my 3s, so now I have to go to the 3p. I can fit 1, 2, 3, 4, 5, 6 electrons there. Still haven't placed all 26 of my electrons. I've placed 18 of them. So now I'm going to go 18 to 19. Now I'm in the 4s. I can fit 2 there. Well, I still haven't placed all of them. I still have a few more to go. So I'm going to come over here. Now remember in the D block, so we know this is going to be a D sublevel. But remember, once you hit the D block, you're going to drop in energy level. So even though we're in the 4th row, we're in the 3rd energy level. And I can fit 1, 2, 3, 4, 5, 6 electrons there. Now, to check your answer, all you have to do is add up all of the superscripts, and that will tell you how many electrons you have. So 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 6 is 26, which is good because iron has 26 electrons. Okay, let's do one more. Let's do iodine. So iodine has 53 electrons. And I could start all the way at the beginning and write one long electron configuration. So I'm going to write that really quick. So it'd be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p, 1, 2, 3, 4, 5. So that would be the full electron configuration for iodine. Now, that's kind of long. So we're going to do something that's called the noble gas configuration. And this is kind of a shortcut. What we're going to do is we're going to find iodine, and we're going to find the noble gas that's closest to it without going past. So the 2 closest noble gases would be krypton and xenon. Now, iodine has only 53 electrons. Xenon would have 54. So we're not going to use xenon, we're going to use krypton as kind of our shortcut. And when you write a noble gas configuration, you're going to put the noble gas that you're using in brackets. So I'm going to start with krypton. And what this is really doing is saying instead of starting all the way back at the beginning, you're starting at that noble gas. So we're going to start here and then finish the rest of the configuration. So starting at krypton, and then we go to 5s2, 4d10, 5p5. So we've taken all of this and condensed it down into just saying krypton. Now, you can't do this with any element that you feel like choosing. You can only do it with the noble gases. And when you write the electron configuration for a noble gas, you can't just put the noble gas in brackets and call it good. You have to go to the previous noble gas and then finish out the electron configuration. Because when we do this, what the electrons that we're going to be concerned about later when it comes to bonding and things like that are going to be these last electrons that we're putting in. So those are the ones that we want to show when we write our electron configurations. So this would be the long version, this would be the short. This is the noble gas configuration, this is the full electron configuration. And so now you should be able to write electron configurations for any of the elements on the periodic table.